In this video, we're going to find the first derivative of this function xy equals 1. We're going to do this two ways, first using existing techniques, then using implicit differentiation. Okay, let's begin with existing techniques. That is, let's start with x, y equals 1 and rewrite this as y equals 1 over x. We can rewrite this further as x to the negative 1 power. So dy over dx, that is the derivative of y with respect to the variable x, is equal to negative 1 times x to the negative 1 minus 1 power. Again, I just applied the power rule where I moved the exponent to the front and subtracted 1 from the exponent. This simplifies to negative 1 over x squared. Now let's try this using implicit differentiation. So that is, this time I'm not going to rewrite this. So I want the derivative with respect to x of xy on both sides. So on the right-hand side, this is fairly easy. That's just going to be 0, since the derivative of a constant is just 0. On the left-hand side, we need to apply the power rule. X is just a function, f of x equals x. And then we're treating y as a function of x, but we don't actually know what it is. So let's apply the power rule. That is, I want the derivative of x with respect to x times y plus x times the derivative with respect to x of y. The derivative of x with respect to x is just 1. So this is 1 times y plus x times, and now we don't actually know what y is, so this is like writing y prime or dy over dx. And this equals 0. So the goal in both cases is to find the first derivative of this function y with respect to x. So let's go ahead and try to isolate this. X times dy over dx is equal to negative y, and dy over dx is equal to negative y over x. But what was y? Well, recall y is just 1 over x, so I can replace this y here with 1 over x and end up with negative 1 over x squared. So as you can see, we end up with the same first derivative using existing techniques or implicit differentiation. You might be wondering, why did I use implicit differentiation if I could just use existing techniques? While this expression may be easy to rewrite as a function of x, this is not always the case. And when this is not the case, we need to use implicit differentiation. So by using existing techniques and implicit differentiation for the same expression, it's a lot easier to demonstrate that we're treating y as a function of x, which is why when we apply, that is when we try to take the derivative of x times y, we have to make sure we end up with the derivative of y in here somewhere. I hope this video has been helpful.